1, 2, 3. Okay. Now, if this is the child of 1, right? This is also the child of 1. If we ask for the common ancestor of both, who's the common ancestor of both, right? Now, if we ask the common ancestor, so this will be the common ancestor, right? 1 will be the common ancestor of both, right? Basically, we have to find. So the question is LCA, like lowest common ancestor. Okay. Now here we have to find the lowest common ancestors, right? So for this node 2, sorry, for this node 2 and 3, what is the lowest common ancestor we find is 1. Simple, right? If there is some bigger tree, okay, if there is some bigger tree, okay, and we want to find the lowest common ancestor of that some bigger tree, okay. So now see, consider this is okay. Consider this tree is given to you, and someone asked you to find the lowest common ancestor of 4 and 5, or yeah, 4 and 5. Okay, so here you have to find lowest common ancestor of 8 and 5 initially. Okay, so for 8 and 5, the common ancestor, the lowest common ancestor, just below it, just above it, sorry, just above both of those node, common node is 4. Okay, so lowest common node ancestor is nothing, common node okay of, you can say, path from root to node. Okay, if you go from root to node, so the common node, okay, just above the common node, just above, you can add just above. Okay, so if you see, the common node could be 1, 4, 8, right? The path could be 1, 4, 8, 1, 4, 5, right? We know, but we want the last common, right? Last common, 4 is the last common here. So 4 is the last common node that we have here. 1, 4, 9, 8, 5, 12. Okay, now for 8 and 5, the last common node is 4. Simple, right? Now for 5 and 12. Okay, so for 5 and 12, okay, so check. For 5, the next node is parent node is 4, right? For 12, it's 9, right? Both are not common. And again, go to its parent, right? 4 and its parent is 1. This is 1, right? Now both are common, right? So the lowest common ancestor that we can find for 5 and 4 is 5 and 12 is 1. Now, if someone asks you to find the lowest common ancestor of 4 and 5, see, for 4 and 5, the lowest common ancestor is 4 itself. Okay, because see here, the lowest common ancestor is 4 itself, because for 5, 4 is in the path, right? 4 is in the path itself, right? So the lowest common ancestor for 4, 5 is 4 itself. Okay, simple. Now tell me the lowest common ancestor of 4 and 12. You can share the chat box, lowest common ancestor of 4 and 12. If you got what we have discussed till now, then you can share. For 4 and 5, it's 1, correct. Okay, now this is actually a binary tree. Okay, now consider we have BST here, a binary search tree. Okay, then what should be the node, what should be the LCA for it, like longest common ancestor for BST. Okay, so the logic will be same. Okay, the logic for finding the lowest common ancestor in the binary search tree is still the same. Okay, so let me write the lowest common ancestor. Okay. So consider we have a node 25. Okay. And then we have the node here, which is 8. Okay. And one node which is 3. Okay. And here we have value which is greater. So consider 27. Okay. And here we have 30. Okay. And this should be less than this, right? So just add greater value than this and less than this. So we can add 12 here. Okay. And from here we can add value less than this, which can be 10. Okay. And this could be, okay. Consider this is the tree given to you. Okay. This is a BST. Why is the binary search tree? Because all the left and right child should be less, left should be less, right should be greater, right? Less, greater. Okay. And for this child, see, for this one, left is smaller, right is greater. This is correct. Now for this node, it is smaller. This is greater, correct. For this node, it is greater. For 25, this is smaller, this is greater. So the complete tree is a binary search tree. Okay. Now here, if you have to find the LCA, that is the lowest common ancestor. Okay. So for this, what we can simply do is we can simply find the path. Okay. For the lowest common ancestor of the binary tree, we can find the path from root to that node. Okay. For like if you want to find for 8 to 5, 8 and 5. Okay. What we can do? We can find the path. The path will be 1, 4, 8. Okay. And the next one will be 1, 4, 5. Okay. And so once we have the path of both, right? So you can go back in this. Okay. Go back in this and find the previous, which is common, right? Or you can start iterating from this side. Okay. And you can find the common. We can check it, right? So whatever approach is correct. Okay? So just find the path, move from this side. Okay. And find the node, which is the common, the lowest common ancestor. Okay. That you have to find. Correct. Okay. Now, what should we do for binary tree? What should be done for the binary tree? See here, if we want to find the LCA of 10, okay, and 15, the lowest common ancestor of 10 and 15. Okay, so lowest common ancestor of 10 and 15, just tell me the chat box and then tell me the lowest common ancestor of 8 and 15. Okay, and then the lowest common ancestor of 27 and 25. Just share the results of all of these three in the chat box. It is same, right? It is same as the binary tree because BST is just a binary tree only. Okay. So this share what is the lowest common ancestor of 10 and 5, 10 and 15. So 10 is this, 15 is this. Okay. And then 8 and 15. Okay. And then 27 and 25. So Aniket, you have writing 12 for 10 and 15. Okay. Correct. 12. Oscar 12, then 8, and then for 27, 25, it is 25. Correct. So this is actually the LCA of a, correct. So this is LCA of the these nodes, right? LCA of these two nodes, lowest common ancestor of these two nodes. Okay. Now we know the binary tree. Now we know the BST. In the binary tree, the simple approach could be you can do the level order traversal. Sorry, you can do the traversal. Okay, any pre-order traversal kind of. Okay, and then you can check the path. Then you can simply check the path where the first node which is matching, right? So that could be the lowest common ancestor for us in the binary tree. Okay, this is one approach. This will also take big off and time, not much, not more than that. Okay. Now see what we can do here in this approach. Okay, what can be done in this BST? Is it somehow a little bit better we can do in the BST or something? Okay. Now see, observe one thing. Okay. Now observe one thing in the binary search tree, that is BST. If both nodes are less than the root, okay. So here, if you want to find for 8 and 27, okay, or you can say you want to find for 10 and this thing, right? 10 and 15, 10 and 15, right? So you want to find for 10 and 15. So check the root node. Both 10 and 8, 15 or whatever, 10 and 15, both are less than this 25. Okay. It means if both are less, it means that if it exists, it should exist on the right hand side. Okay. Both nodes exist on the right hand side. Okay. So we move on to the this one for this node. Okay. Now we again check for 8 and 15. Okay. If both 8 and 15, okay, we have 8 and 15. Now we again check if both are less than this. No, both are not less. 8 is not less than 8, right? So both are not less. Now we check if both are greater. No, both are not greater even. Okay. Because if both are less, it means that it should exist on the left side. If both are greater, it means it should exist on the right side. Okay, this is the case when both are not less and both are not greater. So that means either one of them exists in the left side or another one exists in the right side. Okay, and the third possibility could be, well, say one of the node, the current node that we are at is the same. Okay, so in both the cases, if it exists on the left side also or it is on the right hand side also, right? Consider 3 and 15 was there. Okay, so for 8 it exists on the left hand side and 15 exists on the right hand side, right? So what is the common node we have here? 8, correct? Because if you are at any node, okay, and some x value exists on this side, some y value exists on this side, okay, and you are this current node, so this will be the LCA, because this is the lowest common ancestor for x and y. So wherever we are dividing both the values in, because we know that this is a BST, right? Wherever we are dividing both the values in the left and right subtree, that time we are pretty sure that the current node that we are at is the LCA for both of them. That is the lowest common ancestor for both of them. Okay, so we are pretty sure. If it is less, then we move on to the left subtree. If both are less, we move on to the left subtree. If it is greater, like here it was less, right? 8 and 15. So we move on to the left subtree. But here it is not less. If it is less, we move on to the left subtree. If it is greater, we move on to the right subtree. If both the cases are not true, then the current node, the root node that we are at, will be our LCA. Okay, because one of them will exist on the left side, other will exist on the right side. Okay, or one of them is the root node itself. So in that case also, the root node will be the LCA. So simply we can write the approach here, LCA in a BST. Okay, so what we are doing, if both are smaller, then we can ask root to move to left side. Now if both are greater, then we can ask root to move to the right side. Okay, now the third possibility could be one of them in the right side, one of them will be in the left, okay, and the other one in the right. So return that current node that we are at as the LC of the BST. Simple, right? So let's write code for it.